have the second numerical, and what we have to do in this is that we are given observed bearings of the lines of a closed traverse. So we have a closed traverse A, B, C, D, E, and the bearings for all the sides, forward bearings and back bearings are given. And it was done in a place where local attraction was suspected, and we need to find out the correct bearings of the lines. So they already tell us that the local attraction was suspected. So that means the difference in forward bearing and back bearing for some of the lines, or maybe all the lines, is not 180 degrees. And we have to apply corrections to those bearings so that the difference between them comes out to be 180 degrees. And we have to find out the correct bearings. So one way to do it is to uh, see. Uh, well, let's talk about that method ahead. But another way to do it would be to first find out the interior angles using these bearings, something that we have done in the previous numericals. And once I have the interior angles A, B, C, D, and E, I can apply that check for closed traverse. The sum of interior angles should be equal to n minus 2 into 180 degrees, or the sum of the exterior angles should be equal to n plus 2 into 180 degrees. So from that, I can see that what is my sum of angles and how much it should have been, and then the difference between the two can be adjusted equally among all the sides. So let's say if the difference between the two comes out to be 1 degree, and I have how many corners? I have A, B, C, D, E, four corners. So I can apply a correction of 1 degree divided by 5 to every interior angle, and that is how I can evenly spread out the correction. But since we are working with the compass and we have that liberty of using the other uh, method, which is finding out the difference between the forward bearing and the back bearing and keeping it as 180 degrees, we can do it with more accuracy, because now we would be applying corrections to the actual points and not every side or every point. So in the previous one, we were neglecting that where the error actually was, since the local attraction is not same on every side of the traverse, but we were treating it in that way. But in this case, we can actually find out which sides or which points are free from local attraction and where we need to apply corrections. So in order to proceed with this, the first step would be to see that which side is free from local attraction, and the side in which the difference between forward bearing and back bearing is 180 degrees would be the one which is free from local attraction. So if you do quick maths and subtract forward bearing from back bearings or vice versa, and we can see that this side DE does not have any local attraction, because the difference between forward bearing 42.45 and the back bearing 62.45 comes out exactly 180 degrees. So that means the line DE is free from local attraction. And what does that actually mean? That means that the point D and the point E are free from local attraction, because those are the 2 points on which we placed our compass to note down the bearings. So in turn, what that means is that whatever reading we took standing at point D or standing at point E are free from local attraction. So what other bearings did we take from those 2 points? So from the point D, we took the forward bearing of the line BE. So that was one. And then we also took the back bearing for the side CD. So that means the back bearing of the side CD is free from local attraction. And when you subtract forward bearing from the back bearing, if the difference is now 180 degrees, all the error is in the forward bearing of the line, and none of the error is in the back bearing of the line. The back bearing is absolutely correct, because we got the back bearing by stationing the compass at the point D, which was free from local attraction. And the 2 points were D and E. So what readings did we take from the point E? So one reading that we took was back bearing of the side DE, that we already have said is correct. And the other reading that we took was the forebearing of the side EA. So that means for the line EA, if the difference between the forebearing and back bearing is not 180, all the error is in the reading that we took from the point A, because that is where the local attraction is, and there is no local attraction at the point E, which is free from local attraction. So the forebearing of the side E is correct, and whatever the difference we get uh, from 180 degrees by subtracting back bearing of the line EA from the forebearing, all the error has to be adjusted in this value over here and none in the value over here. So this is how this mechanism works. So once we do this, we can find out the error at every point. Error at the point A, point B, and point C. Because point D and E we have already established are free from any error. So we can calculate the errors at the point A, B, and C. And whatever error there is at the point A, B, and C, the errors would be same in every reading, because how much that magnetic substance affects the reading is constant. So whatever reading you take from those points, every reading would have the same error. So if we can find out the value of that error, we can subtract or add in all the readings we took from that point, and then all the bearings would be free from local attraction. So one way to proceed uh, with this question would be to perform the corrections at this line EA, since we know that the forebearing of the line is correct and we can find out the error in the back bearing. In turn, that would be error at the point A. And once we have that error, we can go to the line AB and then start applying the corrections. The other way to do it is by using the point D. So we talked about this CD, that the back bearing is correct for this line and all the error is in the forebearing. And by finding out that error in the forebearing, we are finding out the error at the point C. And once we have the error at the point C, we can go to other lines which has point C as one point, and then we can keep going on with the corrections. So the way I'll be proceeding with this is that I'll be let's see, using the point CD as the first line on which I will perform the corrections. So first we have to see that for the line CD, in the values that we already have, what is the error? So 200 degrees 30 minus 22 degrees 15. So it comes out to be, it should be 180, and it comes out to be different than that, and that value is negative 1 degree 45 minutes. So this is the correction that we have to apply at the point C. Now since we have the correction at the point C, we can find out the correct bearings for the line CD, and the correct bearings, the back bearing would remain the same, 230. So we discussed that this was okay, and this correction, all of it has to be applied on the forebearing of the side. So this 2215 would now become 20 degrees, or should I go here? So forebearing of CD would become 20 degrees and 30 minutes. And now you can see that the difference between the back bearing and the forebearing for the line CD comes out to be exactly 180 degrees, and now this line CD is free from local fraction effect. So the corrected forebearing of this side is 20 degrees 30 minutes, and the back bearing is same as before, and the difference is now 180. So now that we have found out the correction at the point C, we can apply it to other line. in which point C is one of the reference points. So now let's talk about the line BC. So earlier we didn't know what correction and where we have to apply in the forward bearing and the back bearing, but now we have the amount of correction at the point C. And what reading did we take from the point C? That was the back bearing of the line. So over here. So the back bearing is 222.30, and the correction that we have to apply over here is negative 1 degrees 45 minutes. So the correct back bearing comes out to be to 20 degrees 45 minutes. So this now is my correct back bearing for the line BC. And now that I have the correct back bearing, I can subtract 180 degrees from this, and I can find out what should be the correct forward bearing of the same line. So when I subtract 180 degrees, I get 40 degrees 45 minutes. So this is the value that should be over here. And in order to make this value 39 degrees 30 minutes, which was earlier, to 40 degrees 45 minutes, what I have to do is I have to apply a correction of 1 degrees 15 minutes at the point B. So this value, 1 degrees 15 minutes, is now the correction at the point B. So now that we have that, I can move now to the line AB. So now I have the correction that should be applied at the point B. And what is the reading that I took from the point B? That was the back bearing of the line AB. So if I apply this correction, 1 degree 15 minutes to the back bearing, I have to add it, and this becomes 14 degrees 15 minutes. So now that I have the correct back bearing, I can find out the correct forward bearing by adding 180 degrees to 14 degrees 15 minutes, and the correct forward bearing now becomes 194 degrees 15 minutes. And now since I have the correct forward bearing that should be there, I can actually find out the correction at the point A. Now when I have the correction at the point A, I will move to the last line EA, and for the line EA the forward bearing was already correct, and whatever correction you got for the line AB, if I apply it in the back bearing of the line EA, the difference should automatically be 180 degrees. If it comes out to be 180 degrees, that's a check that whatever work you did before is actually accurate. And if after applying that correction this is now 180 degrees, because we are closing the loop, that means you did a mistake somewhere, and you then have to find out where that mistake is. So this was all about the topic of compass traversing, and we'll talk about questions and answer whatever queries you have in the live.